Good afternoon, ladies and gentlemen. Thank you for joining us today. Our event will begin shortly, and we appreciate your patience while everyone is dialing into the call. Good afternoon, ladies and gentlemen. My name is Joni Utesh with Adaptive Corporation, and I would like to welcome all of you to our webinar today. Our presentation is titled Inspection, CMM Programming with Native CATIA V5. Today's event is focused on selecting the right tool for the job, where does CATIA fit, and an explanation of the process. Your presenters today will be Larry Keene and Frank Thomas of Adaptive Corporation. At the conclusion of the webinar, our presenters will be taking questions from the audience, and we encourage everyone to participate. There are two ways to ask a question. You may enter it in the GoToWindows chat interface on the right of your screen. You may also notice you can raise your hand, and we can address your question privately through the chat window. We're now ready to begin, and I will hand it over to you, Frank.
Okay, thank you, Joni. And thanks, everybody, for joining us today. My name, as Joni said, is Frank Thomas. I'm the president of Adaptive Corporation. Adaptive is one of Dassault Systems' largest sales and support organizations in North America. We have offices throughout the United States and Canada. I'm joined today by Larry Keene. Larry is our Western Regional Manager and brings with him roughly 30 years of experience, specializing in quality process improvement and model-based definition business processes as well. Adaptive has brought a variety of solutions to market over the years. Our solutions reside in CATIA, specifically in support of our customers' quality initiatives, as we're going to be demonstrating for you today. Our solutions support first article inspection processes, reverse engineering, and model-based definition. In addition to our expertise in the Dassault Systems portfolio, Adaptive has extensive expertise in Microsoft SharePoint. In fact, we introduced a solution a few years ago that adds workflow to SharePoint. This solution is targeted for common business processes like new vendor approval process, capital approval or capital request process, engineering change order, ECO, ECN processes, just to name a few examples. Now on to our agenda. So we are going to have a couple of polls today, and the polls we use largely as a chance to get some feedback from you, our audience, so that we understand a little bit more about who is on the webinar today, and we could make the webinar a little bit more meaningful specifically for you. After we do the polls, we'll have a couple of takeaways. There are specifically 3 of them today, so if nothing else besides the fancy demo that Larry's going to do for you today, we hope that you remember these 3 takeaways, so we'll highlight those for you after the polls. Larry will do kind of a solution overview so that you have a better understanding of what he's going to be demonstrating to you live. Then he'll follow that on with a live demonstration, followed up with a review of the demonstration and a Q&A session. So now I'll turn it back to Joni, and we're going to do our first poll. Back to you, Joni.
Thank you, Frank. Let me go ahead and launch our first poll. Are you using iJust or STEP to connect with your CMM today? We'll give the audience a couple minutes here to go ahead and vote. And let me share the results. Looks like 67% are saying yes. Back to you, Frank.
Okay, so this is an important poll only because it gives us a feel for how you're communicating with your downstream processes. And the fact that a majority of you are using IDRIS or STEP to do that, that's certainly part of the solution that we're going to be addressing here. We have one more poll. We'll take about another 15 seconds to do that. Back to you, Jody.
Are you using the IDRIS and STEP model to program your CMM? Are you validating your CMM program back to the Native V5 model? If you are using IDRIS, I should say. I'll give you a couple minutes to go ahead and vote on that. And it looks like results are in. Share that. And it looks like 50-50.
50-50. Okay, thanks, Joni. So what this tells us is that some of you, many of the OEMs require that if you are translating native CATIA V5 data to some other format, that you need to go through some validation process to validate that the native or the translated CATIA V5 data is identical to the original, the master model, the original CATIA V5 data. So it looks like a majority of you, or about half of you, are doing that. So it's kind of split right down the middle. So that's very helpful to help us understand our audience as well. So I mentioned that there are 3 takeaways for today. We'll get through these quickly, and then we'll get on to the technical meat and potatoes of the presentation. So the first takeaway is validate by referencing your native CATIA data. By virtue of operating natively in CATIA V5, there is no data translation. The CMM program is fully associative to the 3D model. So for example, if you change a whole location, the CATIA V5 CMM Planner that we'll be showing you today will automatically update the CMM program to reflect the changes. Our second takeaway is supercharge your MBD, your model-based definition. This solution works directly from the 3D model. The programming process references the master model in CATIA V5. There's no need to translate or create other 2D drawings to tell your CMM program what to measure and how to measure it. Since I'm working in the 3D environment, I can see all of the model-based definition information that needs to be taken into consideration when generating your CMM program. The CATIA V5 CMM Planner creates a production-ready program that runs natively on virtually any CMM machine. And our third takeaway is leverage existing hardware and software. By implementing CATIA V5 CMM Planner, we do not require any changes to your existing CMM hardware or software. Your CMM operators do not need to be retrained by virtue of implementing the solution. We post the CMM program in the format of the CMM software currently running on your CMM machine. Now I'd like to turn the remainder of the presentation over to Larry Keene for the technical overview and demonstration. Larry, over to you.
I just want to thank everyone for taking the time today to join our webinar. Appreciate you taking the time out of the day. This is going to be a quick overview of what we'll be covering today. We work with the Native V5 model. This saves one step in the process of not having to create an IDRIS file and then having to validate your translation. All MVs accessible during the CMM programming process. No need to create 2D drawings to see the MVD. Most program functions are a one-click operation in the CMM Planner, making it very fast. The quality of the program is increased because of not having the potential error in translations with creating bad surfaces in IDRIS or STEP. We post to most major CMM software. I think we have like 6 different flavors of DMIS that we post to. So most CMM software that's being out there today, we can post native to that. And one of the big things is we do not tie up the CMM during the programming process. The goal is to have a CMM program ready to run when the part is manufactured. So your CMM programmer is not down on the machine tying up the CMM. You know, our goal is that CMM should be running and programs should be made offline. Next slide, please. Because we are working directly on the CAT part, we eliminate the need to create an IGES or step file. This saves the time of the engineering department not being asked to create derivative data steps for the inspection department. Also, because we eliminate translations, we do not need to validate our program back to the native model. Also, the CMM program is fully associated to the design. I think Frank mentioned that. If a hole in the design changes, the CMM program is automatically updated. Next, please. We will show you an example of MBD on the solid model during the demonstration coming up shortly. Next. I will show you during the demonstration how quickly we can move around the solid model to program virtually any feature. Also control the motion of the probe. You can place points exactly where you want them based on engineering or customer requirements. We can also use other CATIA features like planes and curves to create our inspection points. Also, the V5 CMM Planner improves QA department throughput since we are creating CMM programs offline without tying up the CMM machine. Next, please. Since you are working inside a CAT product, you have the ability to have any holding or NC fixture included in your CATIA model. This typically is not done when using IGES or importing the IGES into a CMM software application. The reason why is because CMM software applications are not typically a CAD system and will not handle such large CATIA assembly models. Next, please. Because your company probably has invested large amounts of training dollars to teach your inspectors how to use the software in your CMM, we post the native inspection code ready to run on your CMM. This eliminates retraining your CMM operators. Because we post to most CMM native languages, we also eliminate the need to change out your CMM controller. This saves you the cost of purchasing all new hardware and software. We also support app source output. This is great if you want to run third-party simulation software like Vericut. Next, please. The training time is hours, not days. You probably already are using CATIA. Basic CATIA functionality is all that is needed to run the V5 CMM Planner. If you can open a model and create a point line in a plane and create an axis system in CATIA, you can run the V5 Planner. The solution can work on a bare bones seat of CATIA. No need for high-end CATIA V5 seats to benefit from this solution. And with that, we'll start our demonstration. Frank, can you see my screen right now?
Yep, we can see your screen fine, Larry. Go right ahead.
Okay. So when we get into our demonstration, as you can see, we are working in a CAT product. So we open up a CAT part and we create a CAT product. And right in CATIA, we launch our inspection planner. So this is a CA application that's embedded right in CATIA V5. So we have a CAT part that's in a CAT product. Like I was saying on the PowerPoint, this enables you, if you want to model your holding fixture, your clamps, whatever, you can have everything in the CAT 5. We start a plan by hitting this icon, and we'll just call this demo. First thing it's prompting us to do is pick where we want our data from. We're going to pick this local datum axis, and then it wants to know how we're going to align our probe to the part. The next pick is kind of how your part is orientated on your CMM. So we'll pick that axis, and we'll say OK. And we started our plan. First thing we can see, we have all of our icons here and here. We organize this kind of the way you use them. All these are motion type things and probe changes and go-to icons. We have hole icons, different ways to measure holes, and we have several different ways to put points on things. So we'll start out with a couple things, like we'll put a comment, report. We want to inspect KC points. So you can put comments in your program. We want to come in here. We want to put the machine in DCC mode. We can come in here and we can. We're seeing the MBD tolerance right here. It's 10,000, so we can put the profile, so we can enter manual tolerances like this. We say OK, so we're creating the plan. We come in here, we can turn on the approach and retract. If you want to put approach and retract, for example, if you want to lift up before a hole or a point, 1/4 inch, we'll put 1/4 inch here. And we can also do the approach and retract of the machine. So let's just put 100,000 here. And you can turn the approach and retract go to off too. You don't have to use that. So right away, let's start out. We'll start out with I like to have kind of a generic go-to point, so my operator kind of would know exactly where I'm starting. I like to use 00003. So we'll start out here. You see the probe right here. We have inside the planner, we have a probe builder. Okay, so you can go ahead and build your own probe and save different probes. We have a customer that actually modeled their 5-axis head because they use this for on-machine probing. It's just a CAT part that's embedded into the software, and then we have these parameters that you can change the length. We also have post-processor settings here where you can mirror the program and do some different things with some of the DEMAS code and stuff. So this is right into your tools options. Okay, so we'll go back to the program. We'll go back to here, and in the tree of CATIA, to show you how that we're fully associative. This particular model had some KC point that had to be inspected. Okay, and we can do that inside the planner. So if engineering gives the inspection department known set points that they have to have, or your supplier, you're able to do that. So we'll go to this icon here, and we'll use the CATIA name, okay, and we'll come in, we'll pick this surface, and we literally can just sit there then and pick the points. We could pick them on the screen, or we could pick them in the tree, either one. Say OK. And you can see we kept the same names that were in CATIA, and we can turn on if we want to print out a roadmap. So we can turn on that. I call it a roadmap, but it shows you where the inspection data is being taken from. Okay, so that's a way to do points that are already in the tree. Now let's say that we wanted through these holes right here. Again, we said that we have these different ways to do go-tos. This is a really fast way to move the probe around. I've never seen this in another software. We can actually pick on a plane in CATIA and indicate a point. So you can see that plane, that go-to move is at 2 inches. So we can go in here, and then we have these holes, and we have different strategies for holes. So this is a 2D hole. So I'll talk to you a little bit about probing strategy. We can measure these holes as PT measures. We can do auto measure, or we can do R measure. And for you CMM operators and programmers, the auto measure would take the control as coming from your CMM settings. The R measure would either probe 3 points in front of on top of the hole and then adjust and goes down, or probe 1 point. And then the PT measure would take the hit points that you have set. So right now we have it set at PT measure. We have an inside hole, not an outside hole is our whole strategy. We're going to probe 4 hits. We're going to go down 50 thousandths. We're not going to probe it a second time. And we'll call these, we'll just call them holes underscore. So everything is named. And literally all you have to do is just pick the curve. We'll change all the approach and track in one pick. So it's a one pick click. You just kind of have to hover over the hole. Now we're going to reverse all the holes. And what we're seeing here is there's our 50,000, so we're going down in the hole, and we're going to keep these red. We'll say OK. So all the holes are programmed. We're getting the XYZ, IJK, the diameter of the hole, all the information to run this part. At this point, I just want to show you, since we don't have a lot going on, I just want to do a playback so you kind of see what we did right now. Kind of see that. We can hit this button right now. We can pick what we want to play back. This is simulating our output file. So we're going to play back. We're going to put the trace on. We'll load the player, and we'll say play. And what that's doing, you're going to see that 1/4 inch move that I put. And you're going to see the 4 hit points inside the hole. And then it's automatically going to create this 1/4 inch go-to move that comes out of the hole. So there's a lot of time saved by the planner calculating all the motion of the probe. And like I kind of said on the PDF, we also, when we post this, we give you an app source file if you wanted to run this in other CATIA NC processes for collision, or if you wanted to run like an VeriCut, it would check for any collisions that you might have. So you kind of get the idea there. So we'll go back into our plan. We'll demonstrate some more ways to create inspection. So now let's say that we wanted to put a grid on this surface right here. We already have this go-to point, so I don't have to create another go-to point. I can come over here. If I wanted to align the probe to that surface, I could pick one of our probe change icons. We can literally pick the surface, and it would automatically do a probe angle. So this particular one, we did a probe angle of 7.5 and 135. That's in the settings when you set up the planner. If the Renishaw probes or other probes become different, you know, like 1 degree increments or whatever, we have that built in, but we can change that. Right now, our default is at 7.5 degrees. And now we're gonna measure this surface right here, and we're gonna utilize these 2 planes for a gridding function. So we can come in here and we can say, I want to perform, this is the wrong icon, I'm sorry. I want to do a, let's say we want to do 100 thousandths or 150 grid one way, and we want to do a 1 inch grid the other way, and this is up, we give this a name, upper OML, so we can pick the surface, we can set the vector. So our 0.15, we want to go from this plane, and our 1 inch, we want to go from this plane, and it gives us, we have 4 different starting quadrants that we can go through. We can say preview, and we can say, yeah, that's probably too many points. Let's just go with a 250 grid. Preview that. That looks better, and we could say OK. So we're able to put points on set XY planes. Another way we can do this is we have other buttons in here, and we'll call this cut 15. We can change the color. And by the way, every one of these, what we're doing, we're creating a geometric set in the CATIA tree, and we're storing all this data. So it's truly associative. It's right in CATIA. So if I want to measure this surface, I could pick this. I can flip the thing, and I can literally pick once, pick twice, pick once, pick twice. So I can almost freehand set a gridding operation and say OK. So that's a really fast way to lay down points if you want to do it freehand. We have another way we can put points on if we just want to do a simple UV grid, and we want to call it, and we want to do 100 points. Let's change the color. We can change the appearance of what the point would look like. We literally have to pick this top surface, flip the vector, and say OK. So we can put points on that way, on the UV, and see that we're changing the names as we go. This is very important, because when we post this out to some flavor of Demas or whatever, and we make a report, our report can stand alone because our points are named like this. Another great way to make points is, let's say engineering requires certain station planes to have points taken on. So let's come over here. Let's come over here and we'll do another probe change. So we'll use this plane that we have here. We'll send the probe over to here above the part. Okay, and let's take advantage of the smarts of CATIA. We'll come in here. We'll set the probe angle. And then we'll go back to the point that we use for the go-to move. And now let's say that we want engineering or a drawing or something is requiring certain sections to have an exact inspection points. We can take full advantage of that. By picking this icon, we can say these are section 1. All right, put it wrong. Section 1. And we'll set the color to red. We pick the surface. We set the vector. We pick the plane that we want to pick. We can say preview. We can see it's going from the bottom to the top. That's fine. And we'll say OK. We can show you that we can turn on the name of the points. These correlate in here, and you can see those are at X 11 inches. So if your drawing was required to you to do exact readings, you could do that. We can come back and do that again. This time we want to maybe say section 2. Pick the surface, reverse the vector, pick that, preview it. Now we're running from the bottom to the top. We can reverse that, and now we can go from the top to the bottom and say OK. And those are section 2, and they're at 12 inches. So again, we're taking all the power of CATIA and utilizing it when we're creating these programs. And then you do some kind of plot or whatever to show where your inspection points are. Again, if you're right here, these are 5-axis holes. I already have my probe angle set, and I have my 1/4 inch. This time I need to do this 5-axis hole. Let's say that I wanted to, we'll call that bore is fine. We want to go into it 100 thousandths. Same philosophy. I come in here, I just pick the inside wall. I want to reverse the last hole. Looks like I'm too deep. So let's go to there. Cancel that. Let me change that to 20. Pick that. Reverse it. You can see where we're going to be there. We'll say OK. Okay. And we come over here. Do the same thing. You can just pick that and then pick that and reverse all holes. Say OK. We don't have to worry about go-tos or anything because we put in our program we're going to be a 1/4 inch away. So it's going to go a 1/4 inch away from that hole. It's going to probe it 6 times. It's going to lift back out, and it's going to move on to the next hole. Okay? So kind of get the idea. If we want to do some probing around an edge of the part, let's kind of come in. We'll show you one more way we can do profile of the part. So let's come in here. We'll do. We'll lift the probe back up to maybe here. We'll change. We'll just come in here. We'll do a 0-0 change. We'll go to here, and we'll do another go-to move over to right here. And now let's say that I want to probe the periphery of this part. I can come in here and pick this icon, and let's say I want to put 3 points, and I want to call it edge. I can pick that surface, reverse the vector, pick this edge. I have it set to go down. Let's go down 20 thousandths. I can do a preview, and I can say OK. Okay. So now I want to come in here. We'll do that again. Pick this surface. this edge, preview it. I want to reverse that, I think, and say OK. Oh, I went the wrong way. So you can come in here, you can adjust that, right-click, delete. Okay, and so you can kind of see I got rid of that. Now I can go pick those points again, or I can continue going around. Another way you could put points on the edge is we could just indicate points. So I could do the same thing. I could do the same thing by picking the, picking the surface, setting the vector, and I can literally just indicate where I want to put the points. So we have several different ways that we can put points on the part, or we can indicate. A lot of customers just like to indicate. So we give you a lot of different controls. One of the features that we're creating right now is called a smart surface. So you're going to be able to pick the surface, and it'll put more points where the curvature changes more. So it'll automatically calculate how many points need to be on the surface based on the curvature. That's something that's being tested right now. So we go through this and we create our points and our holes. We'll turn off this because our model's getting kind of cluttered up. And so when we're all happy with our program, at this point we're ready to post out the program. So we're gonna create a direct. We're gonna put the directory in CMM Planner post. And I'll get rid of these. So we'll come in here. We're gonna post out. Again, like we talked about, we support several different types of posts that we do, on-machine probing, a lot of different DEMIS flavors. Right now we'll just post, let's say we'll post a virtual DEMIS. We generate an inspection plan. When I used to work in aerospace a long time ago, we called this Quade. We also generate an app source file. So we want to post out, we want to post this file, and we're going to browse to where we're going to put it. So we'll put it here. And we'll call this demo1.demis. Hit save and say OK. And what we created now is we created an inspection plan. This is the very important data. This is where it came from Axis System 1. We could have programmed this whole part in aircraft axis or absolute axis and still pick that second axis to align the probe. I just chose to pick a local axis. We have some tolerance information. We have some of the input that the machine is going to be using for it moving around, all of our names, and then we have the different points, different hole information. So Douglas used to call this Cupus, Northrop calls it Quade, but it's basically the key characteristic points. It's what is in our plan. The other thing that we created is an app source file. This file is ready to put in any CATIA NC process or into third-party simulation that uses app source like Vericut. So this basically simulates the exact code that the DEMIS is going to follow for holes and everything. And then what you're going to run on your CMM is you're going to run this file right here. This is your DEMIS file. So this is your tolerance information, the output statement, and your point measurements with the key names in it. So when we go to measure those points, the output will follow those names. Here's your holes. Remember we set it at 4. Okay, we went down into 50 thousandths, so it's automatic. Here's all your important approach and retract. It's going to move a 1/4 inch above the part, and it's going to go down to 50 thousandths. It's going to probe the hole, and it's going to lift back up, and it's going to automatically go over. So it saves you a lot of time in creating a program. The thing is, if we wanted to, we could have turned on, just like in CATIA NC, we could have turned on a clearance plane. So let's say that we would have had, let's say, a bulkhead part with pockets in. We could have set a plane to maybe Z 1 inch, and then we would have never had to worry about leaving one pocket going into the other pocket. So we have pocket type information or clearance plane information. During our program, we could have changed the axis. So if some of the data was called out from a different location, we could have changed the axis. We also could come in and all of a sudden you spent all this time writing this program. If somebody come in and said, well, we need to go back to aircraft space, we could have picked this icon, modified plan, picked a different axis system. All this data would have been updated to that new axis system. We wouldn't have to start from scratch. So that's kind of a quick demonstration of how the planner works. At this point, I would like to turn it back to Frank, and we can go over some benefits, and then we can open it up for some questions. So, Frank, you want to go back to the benefits, please?
Yeah, thank you, Larry. Okay, so to try and wrap up a little bit, we're going to allow time here, by the way, for Q&A. And Joni, if you could pass it back to me, I'm missing the button here. We'll allow time for Q&A. So the way to do Q&A, if you would, right now is a good time. If you have a question, there are two ways that you could ask a question. One way would be via the chat screen on the right-hand side of your display. The other way would be to raise your hand. I think there's a little icon there that has a picture of a hand. So if you raise your hand, this is supposedly new, at least that's what they're telling me on this GoToWebinar utility. We have the ability to unmute your line so that during the Q&A, which is coming up here in a couple of minutes, we'll be able to unmute your line and you can ask your question, and then we can kind of take turns if there are different people that want to have a little bit more of a conversation that's relevant to the entire audience. We can unmute your line and you can ask a question. Okay? So please give some thought to any questions that you might have. Now's the time to ask those, and we'll move on to Q&A here momentarily. So in terms of reviewing the benefits, we talked about these briefly at the beginning of the webinar. The first thing, one of the first things that we talked about, that companies are challenged with managing translated data. So I've got a CATIA V5 data set, and I need to translate it into IGES or STEP to take it into a back-end system to program it. That step in the process goes away, virtually goes away, because I'm creating the CMM program in native CATIA V5. So the primary benefit is there that we eliminate one step of the process, which ultimately saves time and money, right? Second benefit is having access to model-based definition information while creating the CMM program. So one of the benefits that this whole MBD approach brings to the table is for the OEM, they're not creating additional documentation, additional 2D drawing, right? So good for them. But for the downstream, for the suppliers, all of us on this call, we're still tasked with trying to machine these parts and validate these parts. So being able to work in the native CATIA V5 environment, I'm working on the master model, and I can see all of the model-based definition data live, which eliminates the need for extra drawings, and this is the primary benefit, to highlight whatever the MBD data is. The third benefit is need for a third-party application to validate translated data. I know that many of you we've talked to over the years have evaluated a variety of data translation and validation software. That step of the process goes out of the process when you're using this approach. Why? Because we're not translating any data. So the benefit is to you, it eliminates a non-value-added step in the process between engineering and quality. And then finally, costly upgrades to CMM hardware and software, it really doesn't apply because we're able to work with your existing hardware and software. The bottom line is that there is no need to retrain the CMM operator. The CMM operator works just the way that they've worked all along. So this does not directly impact them. So in summary, if you remember at the beginning, we talked about 3 takeaways. So just wanted to highlight these, and then we'll move on to Q&A here quickly. So validating against native CATIA V5 data. The number one benefit that we illustrated here, hopefully, and you feel good about what you saw, is that there are no translations. We're working in native CATIA. You'll be working and have access to all the MBD data in the native model. You saw that during Larry's demonstration. and leveraging existing hardware and software. Again, back to that point that we can work with the existing hardware and software that you have on your CMMs today. So with that, I'll turn the presentation back to Joni. She will read for us any questions that came in via the chat, and we'll try this thing with opening up some telephone lines and allowing you to ask questions as well. So back to you, Joni.
Thank you, Frank. Our first question is actually by Caesar, and he is asking if we can use with pH20.
A pH20?
Yes.
Yeah. That's the pH20. The different probing apparatus on your machine. It really does not matter. We're just you build all your lengths and the tip diameter and stuff, and we're mainly just outputting the AB angle of that probe. And the other thing is, depending on the different flavor of DEMUS or your different output, we create different files that calibrate your probe. Like in virtual DEMUS, we create an external file that you open up and it says, I got these 9 probes, and it automatically qualifies them and calibrates them. In PC DEMUS, we put those probe angles right on the top of the DEMUS file. So if you open up a PC DEMUS program, it'll say, Mr. Operator, these 4 angles are not qualified. Do you want to qualify them now? And you say yes, and then it'll go and calibrate them on the master ball. So if I'm understanding your question right, it will not make difference with this package. Hopefully that answered your question.
Also, Richard is asking collision detection.
Yeah, Richard, what I demonstrated there is currently in the V5 Planner, we have full simulation with the trace turned on, like you saw. There is not collision detection in the Planner. There is collision detection if you built that into your CATIA NC process, or if you were using a third-party application like Vericut. We are looking at adding collision detection in the Planner. We probably are going to have to be calling up a DMU workbench to do that. Right now, the V5 Planner runs in a bare bones seat of CATIA. I call it the CAT Express. I mean, it's a $10,000 configuration of CATIA. You don't need to have a costly high-end CATIA seat. But we are currently looking at adding collision detection, but you'll probably have to have the DMU license to do that. But again, you can do it if you have CATIA NC inside an NC process, or if you have third-party applications like Vericut. Hopefully that answered that question. Next.
Any import of measured results back into CATIA?
Yeah, what we have is we have another product that it's not this product. It's a product that that we also support and sell. It is called iCompare It, and it will take your CMM results and we'll go back into the CATIA tree, and then you can see the deviations inside CATIA V5 model. Like Frank said earlier, we have other solutions that works inside CATIA. This is a very good solution. It's out there in aerospace quite a bit, so we never thought we needed to redo that. We are making a best fitting solution inside the Planner where you're going to be able to bring measured points back in on top of the model. That's not released yet, but it's coming soon. But right now we do have a solution where you can bring in the DEMUS report, like from PC DEMUS, Cameo, Virtual DEMUS, Open DEMUS, different portable measuring software like Verisurf or Spatial Analyzer. You can bring the measured data back in. It goes into a CATIA tree, into a geometric set, and then you can run an analysis on it, and it'll give you the distance to the model, and it'll give you the true position of holes. So there is another product that we like and we can get you information and demonstrate that if you're interested. It's called iCompare It. Next.
Can you handle a probe changing rack?
Not currently. That would not be a major thing because it's just a line of code saying to go change one probe to another. We love to work with you, and if you saw that this software was a good fit for you, but you needed to add that, our post processor is embedded inside the product, and our post processors are customer driven. So if the customer has if a new revision of a software comes out and we have to change our post or add a post, more than willing to work with you on that. So I don't see that as a problem because it's just a line of code that says go get this other probe out of the rack. So no, but no problem implementing that. Next question.
Okay, and then one last one. I use a Tessa Star M articulating head. Is that model available?
You know, I apologize, but I'm not familiar with that probe. Again, if we wanted to, we offer a service that we could model that probe for you and put that inside the planner. That would be a service charge, and then if there's different, typically on star probes you have 5 different locations, and in the post processor, I'm not sure what software you're using, but we would get the line of code that calls up the different locations of your star probe, and again, that would be something that we could add in a post. So I don't see that problem. We would have to work together and model your probe though. Your cluster probe. Again, like I showed you earlier in the demonstration, guys, that the probe that's in the planner is just a CAT part. It's a parametric CAT part that the planner launches. You could change that to other probes. Like I say, I have a large OEM right now that does on-machine probing, and they modeled their 5-axis head, and they have the same parameterized settings. And instead of seeing a Renishaw probe come up, you see their 5-axis head of their milling machine. So it's just a CAT part that has different parameters on it. Any other questions?
I think that is it. We have one comment from Gulfstream Aerospace saying they use CATIA V5 for more than 50 CNC machines and 2 CMMs.
So Larry, I had a couple of questions that popped up on this end, and I think you may have touched on a few of these. Let me see. Can you simulate movement of the probe?
Yeah. Can you give me the screen, the controls back?
Yep, coming back at you.
Okay.
Okay. Go ahead.
So we have our program here. We can go down on our keyboard and just hit the down key and go through our whole program. Okay. So that's a quick and dirty way that we can simulate the program. We can also hit this button right here and say that we want to simulate. We want to show the trace. We want to load the player, and we want to say play. So that is actually putting the probe trace and going exactly what's going to be measured. So the next step after this is if you had full collision detection, where if you missed a go-to move, it would show if you interfered and hit the part, and that's where like a software like Verific comes in.
Okay, that's very helpful.
Hopefully that answered that question. I'll let this play while we're talking.
I'm sure it did. Even I can see that. And again, I think you touched on this, but I'll ask the question since this one came from Ken. Ken asked, do you support on-machine probing? I think you talked about that briefly.
Yes. Yeah, Ken, that's a very good question. Right now, currently, we post to a few different GCode formats, and like you saw that we post to app source. I have customers take our app source file and put it in their own post to create on-machine programming. I also have customers that post to Caps and Edges Demas, and then Caps and Edges Demas turns it into the proper G-code for their machine. We also have customers that post to PC Demas NC. They read in the PC Demas, and when it goes into PC Demas NC, it turns it into the proper G-code. So there's different ways, and then we also post to just generic G-code, and I'll show that real quick here. We can come in here and we can say I want to post, and I want to post to Fanuc G-code, and I want to post this product. Go here, and I'm going to call it G-code .txt. Say save. Okay. And if we come in here, I can show that we have G-code, but it opened up in the wrong. Let's see. Open with. It needs to open in Notepad. Let's rename that TXT to dot. I think that might help. There you go. So there's our G-code for doing it. So we can and you know, G-code is kind of like Demas. We can create a new post. This is kind of very generic G-code, but again, we're very customer driven. If you have certain G-code, certain on-machine probing that you need to use, like if you already have the Caps and Edges and PC Demas NC, we output the app source file. Some of our customers like to take this file right here and run this through their own post processor to create the G-code that's needed on the machine. So there's several different ways to do on-machine probing. So you know, we'd work with you and do the best way.
Okay. And one
any other questions?
One last real quick question, Larry, that popped up here. This is from Tommy. Asked if where was it? Can you edit properties in the feature tree? I don't know if he's looking for something specific there, but I remember you mentioning something about the feature tree earlier. Yeah. What do the properties look like in the feature tree?
Yeah. I think what he means by that is right now, if we come in here and we say that this go-to move is right here, if you see, we can right-click here and we can cut and copy and paste and delete and different things. Tommy, we know we need to do this. It's on the drawing board. It's on the wish list, but we're going to have an edit feature there. And when you click that and you hit edit, the original panel will open up. So what the plan is this panel right here that created that will reopen up and let you come in here and say, no, I want to change that to 2 inches, and then here it will change. It's a very good question. We know that we need to add that. It's just right now we have some other things that customers are requesting. So we get requests. Like I said, we're customer driven. We want to. You guys are the experts. You know your process, and this product is very focused on solving our customers' needs. So that is coming.
Okay, one other last quick question, Larry. This came from Mario. Mario is asking, is the solution best for stationary CMMs, or can it be used on laser tracker and portable CMMs?
Where it can be used, where I use it on, we have a Ferro arm, Mario, and I use a VeriSurf, and we also sell VeriSurf software. Where I use this solution is if I want to set specific measuring points. If I create these points in CATIA, okay, and I save the CAT part, and I go into, we'll use VeriSurf for example, with the CATIA read. If I read this model into VeriSurf, these points come in, and I can highlight all the points, and I can say make an inspection plan in VeriSurf, and then execute, and VeriSurf will prompt the user to measure each one of these points. And then inside VeriSurf, with a ferrule arm or a roamer arm or a laser cutter or whatever, you could put an auto trigger mode on, and you can say, if I get within a couple thousandths of where this point location is, automatically take the point. So as you pass over the point with the probe, it automatically triggers when it gets to the point. So is it done a lot? Probably not as much as a DCC CMM, but it is a good way to create your inspection points on the model, and that way you don't need to worry about a translation. Because going into these products like a VeriSurf or a spatial analyzer, even though they say they have CATIA read, it's still considered a translation by the OEMs. That is not a pure V5 inspection. They reverse engineered the CATIA file, and they're able to open it up, and it is considered a translation. So yes, you can do it, if you wanted to retain the points. And keep in mind, like we talked about, those points are right in CATIA. So those points are right here. So all those points are in CATIA. So when you read them into a portable measuring apparatus, they will come in with those names. So hopefully I answered that question.
Yeah, I think so. Thank you, Larry. We still have some questions that are kind of trickling in, and in the interest of trying to wrap up on time today, let's go ahead and conclude the webinar here momentarily. Like I said, there were a few of you that are kind of hitting us with some questions here right at the end. We'll make sure that we follow back with you, maybe even yet today, to make sure that you get your questions answered, maybe solicit some feedback from the webinar as well. So in terms of next steps, a couple of options here. Certainly we could continue business as usual, which is going to involve some level of translation if you don't have a direct interface to go from the CATIA V5 master model directly onto your CMM and program it there. So there is a cost for doing nothing, because I think hopefully we demonstrated to you today that there's potentially a time savings here that we might be able to help you with. So a couple of things that we could offer you. One would be to conduct a quality process audit. So that would be for us to come on site and spend, whether it's a few hours with you or whatever the case might be, to just kind of look at your process today and where, how are you going from engineering through programming and onto the CMM machine. There may be some areas of opportunity here that we can help you save time, and time is money, and that's what this is all about. If there's anything that we could bring to the table to help you save time, we'll certainly love to have that conversation with you. Another option would be to perform an evaluation process of the software. It's not uncommon that we do trials of the software. It's a mechanism for you to get something in-house, get your hands on it, and for you to determine firsthand if there's a potential fit in your organization. So if that's of interest to you, we'd love to have that conversation as well. So in closing, we'd like to thank you all for being on our webinar today. On behalf of Larry Keene, Joni Utesh, and myself, I'd like to thank you for being on the webinar today. Please visit our website for future webinars. I'll turn it over to Joni and get things wrapped up and say thank you again, everybody.
Thank you, Frank. As Frank said, thank you everyone for attending today, and please visit our website, www.adaptivecorp.com. And again, we will follow up with you after the call within the next few days or so. And enjoy the rest of your day, everyone. Bye-bye now.